in this lab, we will use Kirchhoff's rule, which are Kirchhoff's voltage law and Kirchhoff's current law, to analyze a circuit and verify the conservation of charge and energy through measurements of current and voltage. Kirchhoff's rules are some rules developed by Gustav Kirchhoff and are based on the conservation of charge and energy. The junction rule states that the total current entering a junction equals to the total current leaving it. The loop rule states that the total voltage around a closed loop equals to 0.
Okay, so the materials we used in this lab were 4 resistors with different resistance each, the Pasco 850 universal interface, this program over here, and we used these cables to measure the current and voltage.
So we're gonna build the circuit to figure out the voltage and current for the third resistor. So first, we have labeled all of our resistors.
This one's resistor 2.
This is 3, this is 4, and this is 1. So first, what we know is which ones go in series and which ones go in parallel.
When they're in series, you add them like this, right? And then when they're in parallel, you add them like this.
Yes. So first, we're gonna start with resistor 2 and resistor 3. So first, we're going to put them. First, we're gonna put resistor 2 into the positive.
To the positive right here.
And then resistor 3 into the negative. So the next part is we have our resistor 4 and our resistor 1, and we're currently trying to measure resistor 3. So we're going to put resistor 1 to be
parallel with resistor 1 and resistor 2.
So finally we have our fourth one. So that one we're just gonna add on top of resistor 1. And then the next part is
we're gonna test them out and put charge into them. So this is the positive, right? This is the positive charge, like voltage, and then this is the ground. Right? So we're gonna put the positive voltage. Let me see, baseline right here. And then we're gonna put our ground right here.
So now we just need to connect these. So this one goes connected on this side, which is, like we said before, resistor 1. And then this last one goes over here at the tip of resistor 3. So then when that's connected, we should be able to get the same result that we got before, and that's what measures out your voltage and current. So for our procedure, we were supposed to find the voltage and the current, which was measured in milliamps for each of the resistors. So for example, right now, what we did is calculate the voltage and the current for resistor number 4. So the way that we did that was we have our resistors 2 and 3 in series, our 1 in parallel, and our fourth one in the middle to be able to calculate for the voltage and the milliamps for that. So here you see resistor 3, and then here you can see this is resistor 2, this is resistor 1, and this is resistor 4. And here that's calculating resistor 4. And then we'll go more into depth on the numbers and the data and analysis. But for the rest of the ones that we did was somewhat similar. The only thing that was changing was the order of the resistors. For example, on this one, which was our resistor 3, this one was also set up so it could be in series and in parallel so we could figure out the resistor 3, and that gave us our voltage and milliamps as well.
So when we carried out this experiment, this is what we used as the source for the voltage, and this is what we used as a source for the current. This is what we got for each one. So for the first system, then for the second, for the third, for the fourth, and we calculated the percent difference with these tables. For the first one, we got 0%, then we got 0.28 difference, and then we got an 18% difference. So this one was the one that came out the most different for us. Overall, it was a very good experiment, and we came out with similar and accurate results.
Okay, so for our conclusion, we concluded that putting resistors in specific formats, such as in series or in parallel, affect the way the voltages of the resistors and the currents passing through the resistance are through Kirchhoff's voltage laws and Kirchhoff's current laws. Today in this lab, we understood what these laws are and how to apply them to any circuit. And yeah.
Miss Gabby and I did the procedure.
Emily and I did the H reduction.
Hi, I'm Gabriela. I did the tables and the data analysis.
Alan, I did the materials and the conclusion and a little bit of the procedure.
I'm Itzel. I recorded and then I edited the video.